Okay guys, in this video we're just going to look more at quadratics, specifically at a standard form quadratic. So if we remember, the standard form is ax squared plus bx plus c. Okay, that's standard form, and where a, b, and c are constants. Okay, you should have already done, I think, the Excel where you were identifying important features of a quadratic using the graph, and it's pretty easy on the graph, right, to just like point out the y-intercept and count up to it and find the vertex and count, the points to that. But there's going to be times when we're given an equation and we want to be able to find those same important features, but from the equation. Okay, so I'm going to show you guys how to do that just through an example. So here's the standard form of a quadratic equation: x squared plus 2x minus 6. And it would be like y equals, or f of x equals. And then the question would be find the y-intercept, the axis of symmetry, the vertex, and the minimum value. Okay, so the very first thing, find the y-intercept. If we have a standard form equation, if you remember back to the last video, what is the y-intercept of a standard form equation? It's just c, right? And why is that? Okay, it's because, let's think about a graph. The y-intercept is what? Where it crosses the y-axis. And what does that mean about x? It means, sorry guys, it means that x is always 0, right? So wherever x is going to be 0 right there. It doesn't change, right? X equals 0, x equals 0. So what we can do in our equation is just plug in 0 for x, right? 0 squared plus 2 times 0 minus 6. This 0 plus 0 minus 6, so our y-intercept is equal to negative 6. Okay, so that's kind of the math behind why our y-intercept is c, but you can also just remember it's c, or plug in 0 as your x value, and that's going to give you your y-intercept. Okay, so y-intercept is negative 6. Then the axis of symmetry, and what we talk about, what was that? Let's think back. I'm just going to draw a random one. The axis of symmetry was the line that went through the vertex where the quadratic could be turned about it, and it was the same on either side. So exactly the same, and that's a bad drawing, but basically it's just a point that goes to the vertex, and we're going to have a formula for that. Okay, so the formula is x equals negative b over 2a, and a and b come from the standard form. So in this case, we've got x equals negative b, b is 2, over 2a. And what is a? A is just 1 over 2 times 1. So x equals negative 2 over 2, x equals negative 1. And that's the equation for the axis of symmetry. Make sure when you're working like on Excel or answering a question, and it says, what is the equation for the axis of symmetry? You want to give x equals negative 1. Just think about that on a graph. It would be x equals negative 1. So let's pretend that's about negative 1. It would look like that line. It's a line. It's not just a single point. Okay. So we already know, now we know two things. Let's just start a little sketch about this graph, right? We know that that's where the line of symmetry is going to be, and we know that the y-intercept is negative 6. So let's put it about right there. Okay. Then, how would we find the vertex? Well, I just told you, right, that the axis of symmetry goes through the vertex. So that means we know the x value of the vertex. So we get the y value of the vertex by plugging in this x value. So y equals, we know the x value is going to be negative 1 squared plus 2 times negative 1 minus 6. So that's y equals 1 minus 2 times negative 1 minus 6. Y equals negative 7. Okay, so the vertex is at x is negative 1, and what was y at that point? Negative 7. So negative 1, we know it's on this line, and negative 7 is just going to be a little below negative 6, right? And that's the vertex at negative 1, negative 7. Okay, so now we can actually kind of draw this, like, pretty good sketch, right, of this quadratic. So it's going to look the same on either side, and that's kind of what it's going to look like. Okay, now this is something a little different. It asks just what's the minimum value. what's the smallest this function can be? And when it's talking about that, it's asking y value wise. So the smallest it's going to be, the minimum value is -7 there. Okay, so those are the 4 different types of things as of right now that we might have to identify about a quadratic just from a standard form equation. Okay, so you might have to go back and watch this video again. If you're doing IXL and you get stuck, you might want to take notes on it, and you can always email me or call me and ask me about any of these problems. Okay, now before we move on, I want to show you one last thing. This is a Desmos graph of that same exact thing. Okay, so I came to Desmos and I could check my work, and we see that, look, -1, -7, that was the vertex. The y-intercept was 0, -6. So these things show us, and we know that the axis of symmetry would have been along this line that the vertex went through. So you can kind of check your answer with Desmos if you wanted to, or your graphing calculator. But we still need to be able to identify them from the equations. Okay, have a good day.